I'm Marco, and this talk is about iOS Wi-Fi and some Sandbox topic. So a little bit about me, very briefly. My name is Marco Grassi, and I'm a member of Keen Security Lab of Tencent. And previously we were known as Keen Team. And my main focus is iOS, Android, macOS, and in particular Sandboxes. And also recently I'm doing a little bit of virtualization. In the last 2 years, I've been member of some .1 teams for macOS, iOS, and VMware. And if you want to follow me on Twitter or stay in touch, my Twitter handle is Marco Grassi. What about Tencent Keen Security Lab? We were previously known as Keen Team, and we are a white hat security researcher. And we usually compete in .1, and we are based in Shanghai, China. And our blog, English blog, is at that link, and our Twitter is that one. And if someone is interested in joining, please ping me. So a high-level agenda, quite traditional, let's say, some introduction, and then we will check some bugs and some more technical topics, and then make some conclusions. So some introduction on how this research was done and why. So back in 2015, I joined Keen Lab. And there was mobile .1, so I started looking to work on the iOS category. And in 2014, for mobile .1, there was the Wi-Fi category. So for 2015, it was natural that I started considering it and to evaluate alternative attack surface compared to the regular pawn, like the malicious link in the browser. At that time, there was iOS 9. Unfortunately, the mobile .1 2015 was cancelled, the official one. And so I just keep the bug, hoping that CDI will add the mobile targets to the desktop .1, but they didn't do it. So after the desktop .1, I just disclosed the bug, since there was no point in keeping them longer. And it turned out to be the right choice, because in mobile .1 2016, there was no Wi-Fi category. So the rules last year changed, and in 2016, mobile .1, the only allowed way to attack an iOS device was through a malicious URL that will be open in mobile Safari. And last year, it was not possible to touch the Wi-Fi or Bluetooth or whatever. And from this malicious URL, you have either to steal some sensitive data or install an application. And that's sad, because in 2014 and the previous year, there were more targets, such as proximity network or baseband. So some previous related research on iOS and Wi-Fi. It was targeted in 2015 by Mark Dodd at RacksCon, and he made a great presentation on AirDrop as a target. And I really suggest you to check his slide and research, because it's very interesting. So what about Wi-Fi on iOS? Maybe you noticed that there is something called the captive portal. And for example, when you are at Starbucks or at the hotel at Marina Bay Sands, when you join a Wi-Fi, what happens? Well, a captive portal pop-up is bring to the front of the user automatically without clicking anything. And that seems a promising target, because it's rendering HTML content. And I find it interesting that on iOS, this procedure is automatic when you join a Wi-Fi. But on Android, usually it's not, except some customization or something like that. You have to click a notification to sign in to the Wi-Fi. A little bit of curiosity. It's funny because in the last WikiLeaks, in the Vault 7 dumps, there was also some bit of information about the iOS captive portal, and I found that interesting. So what about captive portal on iOS? How does it work? As a user experience, you see a UI that pop up when there is a captive portal system in the network, and this UI is called websheet.app. And websheet.app is a system application, and it resides in the application folder, as you can see in the screenshot. And but how does it trigger? So when you join a Wi-Fi network, your device will make a request to a predefined URL to see if it's reachable. And this URL is captive.apple.com/hotspotdetect.html. And actually, also other devices made similar procedure, like Google queried their own server to see if they are reachable. And if the server is reachable, it will return to you normally this HTML content, like success, title success, body success. And but if something happens to the connection, such as a redirect or a different HTML content is returned, then WebSheet will be prompted to the user, showing the HTML content or the redirect in order to make the user log in into the Wi-Fi. So very bad drawn schematics. It's about this is a regular Wi-Fi without any captive portal. So your device will ask captive.apple.com for hotspot detect, and if the Apple server is reachable, then it will return a HTML page with success in it. It means that the network is unlocked and your device is good to go. There's no need to make you log in into a captive portal. What happened with a captive portal appliance? Your device will ask for hotspotdetect.com on captive.apple.com, and the captive portal device will not make you reach the internet because you didn't log in. So it will send you a redirect or different HTML content, and this content or redirect will be rendered in websheet.app and make you log in. So websheet.app use a web view internally and doesn't have the GIT because it lacks of the entitlements. And but still, it's a Webkit, so it has bugs and can be used for initial code execution. So that's roughly the plan of attack. First, we want to create a malicious Wi-Fi network, create a fake captive portal device in order to exploit this behavior of triggering the WebSheet application, and we can serve an exploit with it. So how do you create a malicious Wi-Fi network? Well, it turns out to be pretty simple, and your most easy way is probably to use a Linux machine because there is a lot of stuff already made. Ubuntu is fine, and you just use a Wi-Fi dongle that can go into access point mode, and just pick a Wi-Fi dongle for word driving, and they work fine. Then you need DHCP and some other network stuff, like to make everything work correctly. And then you need something to man in the middle or redirect or have some control of the network in order to hijack this request. And I use man in the middle because it's in Python and it's easy to script and make return what you want. So in this way, we can serve arbitrary content into WebSheet. So we will not discuss any WebKit bug here because the presentation is not about the WebKit, but you can use a WebKit bug. I mean, there are a lot of resources and a lot of previous bugs, and if your device is vulnerable, you can use them. And for example, recently there was the Pegasus WebKit bug, which is used also on other applications like console or and something like that. And you can use that if your device is still vulnerable. Or maybe another good resource, it's previous Pont2On competitions, Project Zero issues, and also the FRAC paper by Saelo, which is about the JavaScript core. So just redirect to or return the exploit to render it in WebSheet and get the code execution inside the WebSheet. So, but now, where do we have code execution? Well, if you know iOS, you know that like a very important pillar of iOS security is the sandbox. So the first thing you should do usually is to evaluate the sandbox profile of that context. And turns out that Apple, of course, think about it, about this. Since WebSheet is rendering untrusted content, it's also running in a very tight sandbox. And in fact, this sandbox is almost like the mobile Safari renderer process sandbox, because they are both processing untrusted data. So it makes sense to sandbox it as much as possible. But notice that I say almost because there are slight differences, and we will check them later. So WebSheet lacks of dynamic code signing because performance were not critical in that context. So there is no way, there is no need of a GIT page to speed up the content. So as you may know, iOS have the code signing, so you cannot run your stuff if there is no RWX page for the GIT. So you will have to reuse existing code. So is this attack vector new or unique? Of course not. It was already used in other contexts, and the first that come to my mind because it's recent, it's the Nintendo Switch. And basically, the Nintendo Switch supports basic captive portal functionality, and it can be used to open a WebKit on the Nintendo Switch. And it turns out that until 2 days ago, the Nintendo Switch was vulnerable to the Pegasus bug. So a lot of some people online make code execution inside that. And it's funny because also this one lacks of GIT. And yeah, I would like to thank Luca for the picture. So after getting initial code execution, usually what do you do? Usually you try to escape the sandbox because you are confined in a limited environment. You cannot do much. So the main targets, reasonable targets for sandbox escape are Usermode privilege process or kernel. So you can either use Usermode the sandbox escape bug in a privileged process or a kernel bug. So what about Usermode bugs? Well, like I mentioned before, we use in mobile Pont2On, we had 2 Usermode bugs, and we successfully bypassed the mobile Safari sandbox. Or you can use something else. So in 10.2, I got this CVE from Apple that there was a sandbox problem from WebSheet, and it says that a sandboxed process may be able to escape the sandbox. And let's see that problem. So CVE 2016-7630. It's about the WebSheet, like the advisory was saying. Like I said before, this WebSheet have a similar sandbox profile to the web content process, which, by the way, is the separate process in which the mobile Safari application will render your web content. They are similar. They can access the same service, same drivers. For our purpose, they are basically equivalent. So I'm not showing these two Sandbox profiles because they will take like 30 slides. And the real difference is that entitlements are quite different. So entitlements on iOS, they are basically similar to Android permission. They express capabilities, and they are inside the binary. It's not like InfoPolice that is external. And so let's take a look at WebSheet entitlements. The first thing it caught my attention. It's that it has unrestricted access to the managed configuration, which is an interesting functionality that we will explain in the next slides. And the other very interesting functionality is that it can open sensitive URL, as you can see, and it can do it in the background. At the bottom, you can see that it's running a custom Sandbox profile named WebSheet. And it also, you can see in the entitlements, it also lacks of GIT, of dynamic code signing, sorry. So managed configuration is very interesting. It's related to MDM and configuration profile. To be honest, I don't know all it what can do. I only know the scope of what I use. If you have this entitlement, you can talk to a remote service that is in charge of managing the configuration of this type. So basically, if you see here, there is some Objective-C code. And actually, you can try this with, I don't know, a DUI-lib or something like that, and inject it into WebSheet, and it will communicate with MC profile connection via NSXPC and install our configuration profile. So the code is quite simple. Just decode my hard-coded profile and install it. So how do we create a configuration profile? Well, there is a tool for that. It's called Apple Configurator 2, and it's in the App Store. And I think it's supposed to be used by network administrator or MDM or something like that. And it can basically specify a lot of options for the configuration of the iOS device. And you can specify a proxy, you can embed the certificates, you can add Wi-Fi, VPN, APN settings, and other stuff. It's quite comprehensive. So if we install this kind of certificate, what do we gain? Well, since we can bundle certificates, as you can see here in the picture, for example, I just embed a Burp certificate, a root certificate authority from Burp. And this root certificate authority will be installed on the device. And so now we can man in the middle not only the HTTP, but also the HTTPS that does not enforce the pinning of the certificate, because the device will trust our malicious certificate. And also we have also some other side effect capabilities, such as specifying the APN and something like that. So it's quite powerful. But we are not really interested into that. What we want to do is to use these new capabilities to get into a less restricted context. So the idea is to jump to another app. But which app should we jump? So on iOS, there is something called the URL schemes and CF bundle URL types. Basically, in your application info list, you can declare some URL that your application is willing to handle. And other application can simply open these URLs and use it as a form of IPC. And the app that declares those URL will handle this and be invoked and decide what to do, if handle them or not. Here we can see there is an example of legacy diagnostic URL. So some application declare this legacy diagnostic URL. So this is roughly how it works. So basically there are some callbacks. I will not go too much into the details on this. Basically there are some callbacks in the application that gets invoked when this kind of interaction via URL happen. And invoking it is fairly simple. You just can use system APIs because it's a supported functionality actually. And it's used a lot by Facebook and Twitter, or to open the App Store, or so it's a legitimate system functionality, nothing strange or bugs here. So if you don't have some entitlements when you do this, probably you will get some pop-ups, and so it's not good for us because the user will have to click to accept and to open this. But fortunately, our WebSheet application have enough power to don't prompt any confirmation, thanks to open sensitive URL entitlement and open in the background entitlement. So what we will do is open another application called iOS Diagnostic, and luckily this application iOS Diagnostic was using HTTPS, but now we injected our certificate so we can man in the middle it. And also it was lucky because it's getting some content from the web and we can inject some JavaScript into it. And also even more lucky, this legacy application was on Sandbox. So this pseudocode will just install the malicious profile as we explained, and then it will open the URL triggering the legacy diagnostic URL and opening the iOS diagnostics application, and it will jump to that application, which runs unsandboxed again, and it will fetch a HTTPS URL, and we can man in the middle it, and use the same bug to get code execution out of the sandbox. So iOS diagnostic was I'm saying was because now it's not present anymore, as we can see. It's a application which I don't know the purpose, but I just found it because I was auditing all the URL handler on the iOS and trying to see if everyone was using HTTP or HTTPS. And it turned out that this was. And so we can jump into this. So this is some kind of crappy code of the malicious proxy. As you can see, it's very simple. So the first part is targeting the WebSheet and just serve something. And then if the second one is some request made by the other application. So another consideration, is this jumping through application and web view a new topic? And the answer is no again. You should check this talk by my friends, Flanker and Liu Geming, on Android, and they use a similar technique on Android Mobile.2 in 2016, which I think it's quite good technique because with a single memory corruption you can reuse twice. And so it's a single memory corruption plus logic bugs, which is nice, I think. And also another example is by Loki Hard of Project Zero. It's a little bit similar, but I think it shares some context, some concepts, sorry. And basically from Safari, it was able to jump to the, on macOS, on Safari, it was able to jump to the help viewer. Small video, if it works. So a small video with some shortcuts. So I took a picture of my favorite book. And then I joined my Wi-Fi, which is good. Oh, it's not. Oops, sorry, it's not working. Fail. Oh, just shit. That's okay. I think it's okay. Yeah. So So my favorite book again. So I will join my Wi-Fi network, Marco 123. And you can see WebSheet pop-ups automatically, and I don't have to click anything more. And then iOS diagnostic, and then I got the picture. Whoops. Sorry. So, what changed on Apple side? So in 10.2, now the WebSheet app doesn't allow any more unconstrained access to the managed configuration. They changed the entitlements. And also before, like in iOS 10 beta or something like that, the diagnostic application was removed. So the entitlements are changed. Now there is a different entitlement for the managed configuration, and it's much more strict. As you can see, it's not like a single shot entitlement. Now they separated, like this application can only do the UI installation, which probably requires some user interaction. And then the open sensitive URL have been also, they removed the wildcard for the open sensitive URL, and then now you can open only a preference root Wi-Fi, which is the URL to open the setting application in the Wi-Fi window, and some other one, which I assume it's to open a mobile Safari tab. And like I said, the iOS diagnostic application is totally gone. So let's do some reason and comparison. And so web rendering engine, they have bugs, and we cannot do a lot about them because of the complexity. But we can mitigate this by running everything more Sandbox. And Android, for example, will do this as much as possible. Basically, every application that has a web view, it will run in multiprocess mode, which means that untrusted web content will be handled in a separate, isolated process. And actually, in iOS, I found that there is something similar, but I don't think it's very used because maybe of the documentation, it's explained more like instead of like a sandboxing security measure, it's explained more like a performance boost. Because you run a you run a web view remotely, and it will have entitlement to do the GIT. So some slides ago we say kernel, but we didn't talk at all about the kernel. So I just bring some case study. The first one is the bug using 10.2 for the yellow jailbreak. So this bug was affecting from iOS 10 to 10.2, and actually there are some problems. There are some problems using this bug on 64-bit process because of its nature. So to be honest, I never used it in the WebSheet context of this talk. But anyway, I thought it would be nice to present it as a case study because it's a very good heap overflow, and it was used in the Yalu 10.2 jailbreak. And also this bug is reachable from any sandbox, so I think it's quite interesting. And I found this bug, I don't remember exactly the period, but somewhere in 2016. And Ian Beer of Project Zero independently rediscovered it and reported. And of course, if you pawn the kernel, also the sandbox is compromised and the device is compromised. So what about this bug? This bug is in the Mac part of the XNU kernel, And it's inside this trap called the Mac voucher extract utter receipt trap. And for the one that doesn't know what a trap is, it's basically on macOS and iOS, you have regular system calls, and then you have some traps. And basically, they are also system calls, and they can be invoked from user mode. And if you see the function declaration, it has only one argument that represents the argument passed from user mode by the user. So the first thing that this function does is to copy from user space with copy in receipt size into the SZ variable. And then it do some basic check, like that the size is not unreasonably large. And if you look down, there are a big if-else. This big if-else is basically two paths. One is the fast path, and one is the slow path. The fast path will be using the stack, because the stack is faster. But the stack in kernel, you cannot make a very big stack buffers. So it basically checks SZ to see if it's larger than a threshold. If it's smaller, it can take the fast path and use the stack. But if it's bigger, then it will take the slow path, which is the else, and it's where the bug is, in the slow path. If you noticed before, arg's receipt size is using copy in, and this is because arg's receipt size is a pointer, it's not a length. And here, the developer made the mistake to use it as a length, but instead it's a pointer. It's a user mode pointer, so this value will be extremely big normally, and this will heap to heap corruption if we can trigger it. So it turns out that it's quite easy to trigger, and it can be easily and reliably exploited because copy-in have some very nice feature, which is actually it's quite common in kernel in this kind of functions that copy from user mode to kernel mode. Basically, if copy-in encounters a unmapped page, it will stop the copy, but still it would have copied some content. So we can use this fact because our exploitation problem is that the user mode pointer will be unreasonably big number if considered as a length. So we need some trick to bypass this, and thanks to copying is possible. You can put your stuff on the end of the page and unmap the page after. So you will not have a wild copy. You can just overflow a very small content. And so we can control exactly the size of the overflow and also the content. And this means that this is like a perfect heap overflow bug and can be easily and reliably exploited, as we saw in the YALU 10.2. To end, I thought I might add some iOS 9 bugs that got fixed internally by Apple, but they are interesting anyway. So those are iOS 9.3 kernel bugs, and I'm not sure which device are affected, but on my device there are. And those are bugs in graphics, and this one is use after free from the application Sandbox or the browser Sandbox, and it was fixed by Apple somewhere in iOS 10 or iOS 10 beta, and I think they found it internally or maybe for some code refactor because I didn't find a CVE for it. So, and also please excuse me for the poor coding style. So basically this bug is just opening a graphic, I don't know, OpenGL user client. And then the most important thing is to open also the shared graphic user client, because there are at least 3 or 4 type of graphic user client. And then you have to connect them together with IO Connect. at the client. And after that, you just call one method on the graphic user client. And this method is related to graphic resources. And this method call will cause a use after free condition when you close the user client. Anyway, it was also exploitable and reliable exploit. And then some couple of stupid info leak. As if you are familiar with IOKit, you might know that when you call a method, it will return to you error code. And if in kernel you forget to return something, then the content of some register can get spilled into the return value and leaked to user mode. And actually, this kind of bug I already saw before, fixed by Apple, but maybe there were other ones. But anyway, these two leaks now they are gone, and they were fixed internally, I think, because I cannot find the CV again. So conclusion, and then I finish. I think it's very interesting to compare platform and study other platform to understand difference and behaviors. And some platform have a very good user-friendly experience, but you have some trade-off. Like sometimes it might be a little bit a security risk to add a click or remove a click. And Sandbox are, of course, extremely important to contain attacks and force the attack chain to be longer, which is good for security. And recently, I noticed that a lot of bugs are getting disclosed or fixed internally on iOS and macOS by Apple. So I think the security is getting even better. It was already strong, but even better. And I suggest you to check out the iOS 10.3 security release notes, because it lists a quite impressive list of bug fixes. And I think everyone should really check or at least research on other platform, because I think it's good to get new ideas and apply them in different contexts. So I would like to credit these people, which I respect. And I think that's it. If you have any question, otherwise you can just ping me on Twitter or whatever, or find me around. Thank you very much.